That was his main motivation, is that he went to engineering school and he couldn't believe that going through engineering school he wasn't going to be able to build something. So he wanted to build something to help people build things, and that's how he came up with the idea for Arduino.
Welcome to the Style is Free podcast. We're here with part 2 of the Marco Squared podcast episodes. Now we're here with Marco White, talking about open source hardware and quadcopters. Welcome, Marco.
Hey, Brett. How's it going?
Doing well. So, what is open source hardware?
It's very similar to open source software. Kind of came about with the invention of Arduino, open source circuits that people post on the websites like Instructables or different things, and they just kind of share their designs, and people take them, they build new things, and it's all just for the sake of designing cool stuff.
So what are some projects you've worked on with Arduinos and open source?
Yeah, so I can tell you a little bit about my senior engineering project involving quadcopters and Arduino. Pretty much the project was to build a more intuitive flight interface for flying, and what we had gone with is a motorcycle. Initially designed for airplanes, but we used quadcopters because flying RC planes is just incredibly difficult, even with a normal controller, let alone like trying to prototype some motorcycle interface with a thing. Not really a smart idea, so we went with quadcopters.
So is quadcopter, is that kind of how drones are, you'd imagine nowadays, with the 4 kind of fan-like things?
Yeah, exactly.
Okay.
Like 4 rotors. There's loads of cool like software and like flight controllers associated with quadcopters that make it hard to crash. Things like kind of auto correction, like if you turn too hard one way, like a lot of like neat software you can write with drones to like kind of make them a little bit easier to fly. So it was, in that project, was a good playground to kind of test our interface.
When you say, you were talking about it being a motorcycle before,
right.
How big is this thing?
The exact size of a motorcycle. So we pretty much went on Craigslist, bought a motorcycle chassis frame with pretty much like a gutted motorcycle without the engine. We pretty much just stripped it down to the core frame and the body, attached some sensors to it to get a couple different inputs. The 4 main one, you want 4 main inputs when flying something. You want pitch, roll, yaw, and the throttle. So we had 4 inputs on our motorcycle. The throttle, which is the same thing as a throttle on a motorcycle. We had roll. We used the actual force sensitive resistors on the side of the motorcycle. We had yaw. We used the handlebars on the motorcycle. And then we had pitch. It was the hardest one to design for because obviously in a motorcycle you're flat on the ground. There's no reason to pitch unless you're doing like a wheelie or something. So we had a load cell on the handlebars to detect like if a user was either pushing forward or kind of like pulling back.
So how much did this thing weigh?
Pretty heavy. Like you need like a couple guys to like lift it up. So another part of the project was that we didn't really fully develop was kind of a feedback system where you have kind of a 3-degree of motion platform that would kind of take whatever accelerations you would feel while flying and then try to feed that back to the user if you were to fly the quadcopter forward like really fast. Typically when you accelerate forward really fast, you feel some pressure on your chest, so you can like actually tilt a person back slightly, fool them into thinking that they're moving forward because they'll feel the force of gravity on their chest. Like the idea was like we had like a first person camera on the quadcopter, so if you imagine you're wearing like a headset and you have the perspective of the quadcopter and you feel this force, you might actually feel like you're flying.
So you didn't actually fly with this? It was more of a prototype?
We did fly with it. We didn't build that feedback system loop in though. So there were no like kind of faked accelerations, but it did fly. Not entirely well, but it did work. The whole point was to make something more intuitive. There's actually a lot of parallels between driving a motorcycle and flying. So for instance, if you're going like extremely fast on a motorcycle, if you make a left turn, you actually steer the handlebars to the right. And the entire turn is done with your body. So you will completely lean to the left, but if you were to turn the handlebars to the left, you're going to fall right to the ground. So you actually need a counter steer. Same can be said when you're flying a jet. If you're flying a jet and you're about to roll left, you're going to roll the plane to the left and then pull back, but you actually counter steer with the rudder. There's some analogies there, but yeah, due to like kind of technical limitations, it's just kind of hard to like build something that is really easy to work with. I mean, most like kind of flight interfaces now, right? It's like a stick that you have. It's not built to be intuitive. It's really built for safety because any technology you have in a plane like has to pass like a huge amount of tests. So it's kind of this mechanical system that's mostly designed with the pure intent of like avoiding failure. Obviously, as technology advances, there's more kind of trust being placed in digital systems. So there's opportunity to build a better interface for flying.
Was this electric, this quadcopter that you made?
Yeah.
And the Arduino is powerful enough to run this? Is it just one Arduino, or how much processing power did you have there?
So the Arduino handled the sensor inputs on the motorcycle. We actually had some digital potentiometers mimic the joysticks on an RC controller. And then, so we pretty much hacked apart an RC controller. In terms of flying the quadcopter, it's the same. It's more so the Arduino was mimicking what you would do on a RC controller.
How fast did it go?
It'd go as fast as you could fly with a normal controller. I did not fly that fast. I was very cautious. There were several instances where we almost crashed. We kind of had a limited budget on this project. So like one crash was kind of like the end of our work. So generally like pretty cautious. We also had some backup systems. The advantage of like hacking an RC controller is that you can kind of do this buddy system where you take two controllers and you connect them together, and it's usually used when you're training someone to fly a plane because it's very hard. You can have someone like who's more experienced next to you quickly like kind of act as a master controller, and if you're having trouble, they can quickly take over control and then like try to like recover from a mistake you might have made. So we had a system like that. So if like ever, you're on the bike and like things kind of get out of hand, we always had someone on the side with just a normal controller. They would like flick a switch and then they would get control with the normal controller and like kind of be able to bring things back to normal.
Cool. So when you say you were cautious, 10 miles an hour, what would you say?
I would like literally hovering in space and then just like maybe moving like a foot to the right and then trying to move a foot to the left, like turning around a couple of times. Nothing crazy. We weren't racing quadcopters or anything.
Right. And just to be clear, this is a manned quadcopter. You're actually on the motorcycle?
Yeah, so we're on the motorcycle, and then the inputs that we give on the motorcycle is what's translated into flight controls on the quadcopter.
Cool. And where is the quadcopter now?
The quadcopter actually did die. Like it's done. So the project went on to after we graduated. We pretty much left it to the engineering school, and then it actually got picked up again by a team the following year. I actually got to go. I actually revisited my school, University of Vermont, and met with the team just to kind of like see, like catch up. Like I was interested to see what they were working on, and they had crashed. And they actually ended up getting some flight simulator software. So they were testing flying kind of virtual planes in a virtual environment where you don't have to worry about destroying hardware or anything.
Right. But, after they crashed.
Yeah. So that quadcopter is long gone. Yeah. I'm just glad I wasn't the one to do it.
Yeah. Well, it's crashing anyways.
Yeah. Maybe.
You could have hovered a little bit faster.
Right.
Awesome. So I see a lot of parallels with this quadcopter and flying cars. Do you follow anything with that, with flying car companies?
Yeah, I've even seen flying like quadcopter bicycle things that look actually somewhat similar. Nothing that you can kind of like buy like and market, but it's hard to say if there's really a market for this sort of stuff. I think a lot of it, mostly probably military applications. I think it probably the biggest area where like you might find interest for these sort of things. Yeah, it definitely has parallels to flying anything really with like kind of forward velocity. I think it's much easier if your interface relies more on body movements than kind of trying to think like, where do I move this like kind of like rod and like pulley like type system.
That totally makes sense. Yeah, I actually know a guy who worked for the Pentagon in the Obama administration, so he's not there anymore. But his job was he moved to San Francisco and would take government money and go basically buy startups or give startups a lot of money that were working on really cool stuff. So some examples he was telling me about were flying car companies. The military is very interested in them because they're electric, so they're quiet. They're essentially drones that you can put a person into. So yeah. Where do you see the future of that going, whether military or commercial?
Yeah, maybe. I think, if it is going to be something that's more commercial, I don't know if necessarily having a flying car is really the way to go. I could imagine maybe something like maybe separating the two, having something that can maybe attach to your car that gives it the ability to fly, maybe something that you hold at an airport, for instance. You don't drive your plane on the road. You keep your plane at the airport. So when you're on the road, like if you even get like dinked or something, someone hits your car, like that's no go to fly. Like you're not gonna like be able to take that thing in the air. So like obviously like from a commercial standpoint, it's a huge disadvantage if you're like driving around with tens of thousands of expensive equipment on your car. So maybe something that's detachable, something that you just keep at an airport, like you store your plane at an airport, and you can drive to the airport, attach some wings or whatever technology it is to your car, and then give it the ability to fly. I think that's a little bit more practical.
So you think we're far off from people owning or Ubering
flying
cars?
Yeah, I think we probably got some ways to go, at least for the average day person. I don't think I'll probably own a flying car in my lifetime, but
Right. Yeah, I always thought it'd be very cool because you don't really need infrastructure as much, like roads and stuff, and then it's kind of like going from 2D to 3D, right? You get this whole other axis that you can just stack people on and go straight to places. Like anytime in Colorado and driving through the mountains, it would take 2 minutes if I could just go as the crow flies, as they say.
Right. And then traffic's a huge issue. Like how do you manage all that traffic? Yeah,
especially looking at places like Los Angeles or New York, that traffic isn't getting any better.
No.
Yeah. Awesome. So anything else related to these topics that you think about or passionate about?
Yeah, no, I really love Arduino. I think it wouldn't have been possible to like do this project without Arduino. Like I think Arduino really makes kind of hardware a little bit more accessible to people, and kind of to tie it actually back to the last podcast where we're talking about Europeans like kind of knowing a lot about theory but not really building. I think that was the main when we had that when we had the founder of Arduino come to talk to us in interactive devices. That was his main motivation, is that he went to engineering school and he couldn't believe that going through engineering school he wasn't going to be able to build something. So he wanted to build something to help people build things, and that's how he came up with the idea for Arduino and kind of an easy to use development platform for just hardware. Because I mean, if I've tried alternatives, like if you kind of like go a step above Arduino and use products like Atmel Studio and try to program microcontrollers actually using C. The time it would take to do my project is like the time it takes me to write the Blink program in Atmel Studio. Just doing things on Arduino it's way more dumbed down. I think it gives you a lot more power to do different things, and just loads of companies have latched onto that community, like Adafruit and other like SparkFun, and they release products all the time that have like cool sensors, cool devices, and cool like add-ons that you can add to kind of open hardware projects to just give it all sorts of capabilities.
Yeah, when he came to speak at our class, the founder of Arduino, I really liked his line about when you have a product, you want it to be like a staircase, that it can be difficult to get to the next step, but people see that there's a next step there, and that's all they can focus on and get to the next place. If you give people a wall, there's nowhere that they can go.
Exactly.
They can't climb up a wall. So I like how he's very design focused. Needs to make it easy to use so everyone can get to it.
Right. Yeah, no, I completely agree with that. And I think with like Arduino, if you have any sort of like hardware experience and you have an idea in mind, like building a lo-fi prototype with Arduino, you can do that in like a day or two depending on the project. And it's just like getting something like tangible really quickly is just, Arduino just makes that much more possible than what it used to be.
Awesome. Are there any Arduino projects or Raspberry Pi projects out there that you see that are really cool?
I saw one that was really neat. It was a school. They made like a kind of like a hot air balloon with a GoPro, and I think it had an Arduino and a Raspberry Pi on it, and they sent it up. And it actually like kind of went out into space, recorded awesome footage, beautiful pictures of like, you can kind of see the curvature of the earth. And then they eventually, I think they had some like GPS tracking on there as well. It landed like, a couple states over, but they managed to get it back and like get that footage, and like ended up making a really cool video.
That's awesome. And have you send that to me?
All right. Awesome. Yeah, I will.
Cool. Well, thanks, Marco. That's really exciting stuff about Arduinos, motorcopters, and the open source hardware community. Thanks for coming on the podcast.
Oh, no problem. Thanks for having me.
Thank you for tuning in to the Style is Free podcast. If you want to engage with us more, find us on Facebook at Style is Free Podcast or on Twitter at Style is Free Cast. We are on SoundCloud, iTunes, Google Play Store, wherever you get your podcasts. See you next time, friends, on the Style is Free Podcast. As always, I'm your host, Brett Leibowitz.